Alright, in the last video we looked at the nomenclature of ionic compounds when we know the charge on the metal ion. And of course, that occurs when we have alkali metals, alkaline earth metals, aluminum, zinc, or silver. For all other metals, we have to specify the charge when we give the name. Or when someone gives us the name, they have to tell us the charge with Roman numerals. So the rules are the same, we just have to add one step to it. So if it's just a metal and a nonmetal, I give the name of the metal, I give the name of the nonmetal, but I replace the suffix with IDE, and then after the name of the metal, I just have to give a Roman numeral that has the charge of that metal. And then the same thing if I have a metal plus a polyatomic ion. Give the name of the metal, give its charge with Roman numerals, and then follow it up with the name of the polyatomic ion. Alright, so we'll start the easy way, going from the names to the formulas. Right, this is pretty easy because they just tell me the charge on the metal. So tin 4 oxide, tin is Sn. They told me its charge is plus 4. I know oxide is an oxygen ion. It's 2 minus. If I swap the charges for the exponents, I would get Sn2O4. But both of those subscripts are divisible by 2, so I would simplify that to SnO2. Alright, for iron 3 carbonate, they told me iron is plus 3. Carbonate is a polyatomic ion. So I would have Fe2, and then 3 carbonates, and that would be iron 3 carbonate. Okay, so a little bit harder is determining the name from the formula, because now I have to specify the charge, and so I have to figure out the charge. Sometimes that's easier than others. So with CrBr3, I need to use the nonmetal whose charge I know. So I know that bromine is -1, but I have 3 of them. So 3 times -1, the 3 bromines together is going to make a -3 charge on the bromines. So in order to cancel that out, the chromium has to be plus 3. So my name is chromium 3 bromide. Now sometimes it's easy to do it in your head, and sometimes it's harder. And for some people it's always really easy to do it in their head, and some people struggle a little bit more. So if you have trouble doing it in your head, what I would recommend is we can write kind of a little formula. So if we imagine sort of the general formula for one of these ionic compounds is the cation with some number, right? So I have N cations, and then I have M anions, right? We can write a little formula so that N times the charge on the cation plus M times the charge on the anion has to be equal to 0. Right, so we're using that the charges have to add up to be 0. So you're always going to know how many anions you have. In this case we had 3 anions. You'll always know the charge on the anion. In this case it's -1. From the formula you'll always know how many cations you have. In this case we have 1 chromium. And so you'll always be solving for C, the charge on the cation. Right, let's see what this would look like with this CrBr3. So we have 1 chromium. So I have 1 times the charge on the cation, which is what I'm looking for. I have 3 anions, and the charge on the anion is -1, and that has to add up to be 0. So 1 times C is just going to be C, and then 3 times -1 is going to be -3 is equal to 0. So then I would add 3 to both sides. And so the charge on the cation, in this case chromium, is +3. And so my name is chromium 3 bromide. Right, let's do the same thing with PbO2. So we always have to use the anion. So oxygen, I know its charge is -2. And I have 2 of them. So the 2 oxygens together make -4. So to cancel that out, the lead has to be +4. So my name would be lead 4 oxide. Right? But if you don't like doing that in your head, right, try this little formula. Right? So how many cations do I have? I have 1 lead. So 1 times the charge on the cation, in this case lead, I have 2 oxygens. Each oxygen is -2, and that has to add up to be 0. So I get the charge on the cation, and then 2 times -2 is -4, is equal to 0. So we'll add 4 to both sides. So the charge on the cation is +4. So my compound is lead 4 oxide. All right. We have another example here, another 2 examples. I have Cu3PO4. So now it's going to be, my name is going to be copper. I don't know the charge on copper just based on being copper, so I've got to figure that out. So it's going to be copper, some Roman numeral, and then the name of the polyatomic ion, which is phosphate. So I can write copper, leave a space for the charge, phosphate. And so to figure out the charge, I can do it in my head. I can say, okay, I know phosphate is 3 minus. And so the anions all together make -3. I have 3 coppers to cancel out that phosphate. And so if each one of the coppers is +1, that would cancel it out. And so I have copper 1 phosphate. Or we can use that little formula. And so in this case, I have 3 cations. So I would do 3 times the charge on the cation. I have 1 anion. So it'd be 1, the charge on the phosphate is -3. It all has to add up to be 0. So I would have 3C, and then 1 times -3 is going to be -3 is equal to 0. So 3C is equal to 3. Now divide by 3, so C is equal to 1. And so we get the same thing. The charge on copper is 1, so it's copper 1 phosphate. All right, if we do the next one, I've got uranium. Again, this is a metal whose charge I don't know, so I've got to figure it out. But I know I can look at the periodic table and see that U is uranium. That polyatomic ion is dichromate. And so let's just use the formula this time. This one seems a little bit more complicated. Now I know dichromate is Cr2O7 2-. So I have 2 uraniums. So 2 times the charge on the cation plus 5 times the charge on the anion has to add up to be 0. So 2 times the charge on the cation, 5 times -2 is -10, is equal to 0. And then 2C is equal to 10. Divide by 2. So this is uranium 5 dichromate. All right, and then just 2 more examples. So I have CO3P2. The charge on a phosphorus ion is -3. So I have 2 phosphoruses, that makes -6. I have 3 cobalts, so in order for that to cancel out, each cobalt would need to be +2. So I could say cobalt 2 phosphide. Or I can say I have 3 cations. I have 2 anions that are both -3. It has to add up to be 0. So 3C minus 6 is equal to 0. 3C is equal to 6. So the charge on the cation is +2. Alright, and then finally, our last example, I have Pu, and then the polyatomic ion is HPO4 3. And so I know my name is going to be plutonium. Plutonium is an actinide. I don't know its charge. I'll have to figure it out. That polyatomic ion is the hydrogen phosphate ion. And so the hydrogen phosphate ion has a -2 charge. So I have 1 plutonium. So 1 times C. I have 3 of those hydrogen phosphates. Each hydrogen phosphate is -2. It has to add up to be 0. So C, 3 times 2 is -6. So the charge on my cation is 6. So this is plutonium 6 hydrogen phosphate.